Bismillahirrahmanirrahim. Starting with the great name of Allah, who is the most precious and the most merciful. Assalamu alaikum, my dear students. I hope you all are fine. We will start Unit 3, Fraction and Equivalent Fraction in a previous lecture. There we solved two questions, question number 1 and question number 2. Today we are going to start question number 3, which is cancel or divide each fraction to make it as simple as possible. There we have question number A, 60 and 100. 60 divided by 100. So to make a simple means to reduce a fraction to its simplest form, you need to divide the numerator and denominator by the same numbers. This is sometimes called cancelling a fraction. So to divide numerator and denominator by a same number, as we learned rules of divisibility in a previous lectures, that if we have 0 in the last of the number, that can be divisible by 10, like divide 60 by 10 and divide 100 by 10 also. So divide 60 by 10 means 10 6s are 60 and 10 10s are 100. We can get 6 and 10. So we divide it furthermore, as we study already, that if we have even number in the last of the digit, that can be divisible by 2. So here we have 6 and 0 in the last of the number, so divide both of them by 2. So 6 divided by 2 means 2 3s are 6 and 2 5s are 10. This 3 and 5 is the simplest form of 60 and 100. Okay, we have another question. 16 divided by 20. Same like question number first. In the last of the digit we have 6 and 0. So it can be divisible by 2, or we can also divide it by 4. So 16 divided by 4 and 20 divided by 4. So 4 4s are 16 and 4 5s are 20. So this 4 and 5 is the simplest form of 16 divided by 20. We have next question, and that is, I'm going to solve question number H. We have a question 24 divided by 64. So 24 is also divisible by 2, 64 is also divisible by 2. We need to solve both of them by a large number to get our answer quickly. So we can divide it by 8. 24 is also divisible by 8 and 64 can be also divided by 8. So 24 divided by 8 and 64 also divided by 8. So 8 3s are 24 and 8 8s are 64. This 3 and 8 is the simplest form of 24 and 64. If you divide it by a small number like 24 divided by 64, if you divide it by 2, just check what happened. 2 12s are 24 and 2 32s are 64. Again we have 12 and 32. So 12 and 32 is not simplest form because it can be divided further. So I am going to divide 12 by 4 and 32 by 4 as well. So 4 3s are 12 and 4 8s are 32. So we can get same answer in both the conditions. If you divide a number by a small one and if you divide it by a large number, you can get a same answers, and 3 by 8 is the simplest form of 24 divided by 64. Okay, I am going to divide to solve another question, question number K. Question is 35 divided by 50. So we can divide numerator and denominator by the same number. For this, we learn in the rules of divisibility, if there is 5 or 0 in the last of the number, that can be divisible by 5. So I am going to divide 35 and 50 both by 5, and 50 also divided by 5. So 5 7s are 35 and 5 10s are 50. 7 and 10 we cannot divide it further because 7 is a prime number. Prime number that have only two factors, one and the number itself. Therefore 7 divided by 10 is the simplest form of 35 divided by 50. If I am solving next question, and that will be the last question of this topic, question number G, 12 divided by 18. So both of the numbers are very easy because we know that both of them are come in the table of 6. Divide both of them by 6. So 6 2s are 12 and 6 3s are 18. So 2 by 3 is the simplest form of 12 divided by 18. I think you got the topic. On the same page 21, we have the last one question, question number 4. 2 of each of these cancel down to the same fraction. We have a question here, question number A. 9 divided by 21, 4 divided by 14, and 15 divided by 35. We have a question that 2 of each cancel down to the same fraction. It means that if we simplify all of these fractions, so in the answers of all of them, 2 of each will be the same fraction, but the other cancel down to a different fraction. So we need to find the odd one for each sets. So cancel all of them. 9 divided by 21. Okay, so we know that 9 divided by 21, both of them comes in the table of 3. 3 3s are 9 and 3 7s are 21. The next fraction we have 4 divided by 14. So we know that both of them comes in the table of 4. So 2 2s are 4 and 2 7s are 14. The last one fraction we have 15 divided by 35, and both of them comes in the table of 5. And as we also already learned in the rules of divisibility, that if there is 5 in the last of the digit, that can be divisible by 5. So 15 and 35 both can be divisible by 5. So 5 3s are 15 and 5 7s are 35. Our question was that 2 of each of these cancel down to the same fraction, but the other cancelled out to a different fraction. So these two are same fractions, and this one is the odd one. So this is our required answer. Okay, next question we have question number D. 12 divided by 16, 10 divided by 15, and 18 divided by okay, first fraction we have 12 divided by 16. So we know that 12 and 16 both comes in the table of 4. So 4 3s are 12 and 4 4s are 16. Next fraction we have 10 divided by 15. We already learned in the topic rules of divisibility that if we have 0 or 5 in the last of the number, that can be divisible by 5. So 5 2s are 10 and 5 3s are 15. The last one fraction we have 18 divided by 24. We know that both of them comes in the table of 6. 6 3s are 18 and 6 4s are 24. Our question was that both of them cancel down to a same fraction, but the other cancel down to a different fraction, and find the odd one. So these two are the same fractions, and this is the odd one, and this is our required answer. Now let's come towards the home assignment. As I solve question number A, B, G and H in question number 3, you need to solve the rest of them. And in question number 4, as I solve question number A and D, you may have to practice the remaining question, and if there is any problem, inshallah we will discuss it in the next lecture. Take care.